Okay, now we'll see how to apply histogram equalization. So in the problem, this frequency table is given. Now you can see there are 8 gray level values 0 to 7. So naturally the image will be how many bits? It will be 3 bits, right? Because 2 raised to 3 is 8. So the grayscale will be equal to close interval of 0 to L minus 1, that is 7. Okay, so we'll see the solution. Step 1. Step 1 is compute the running sum of histogram values. Histogram values. Okay, so we'll take this gray level values and this number of pixels and then running sum. We'll do it for all the gray level values. So this is given 100, 250, 100, 300, 150, 0, 0, 0, right? So what will be the running sum? This is 100. 100 plus 250 is 350. 350 plus 100 is 450. 450 plus 300 is 750. Similarly, we'll get 900, 900, 900 and 900, right? So running sum is what? Cumulative addition. Okay, this is step number 1. Okay, then step number 2. Step 2 is divide the running sum obtained in step number 1 by the total number of pixels. Total number of pixels. So how many pixels are there? N equal to 900. Okay. So step 2 will be what? Running sum divided by N, that is 900, right? So again for all the gray level values, we'll do this 0, 1, 2, 3, 4, 5, 6 and 7. So what we'll get here, 100 upon 900 is 0 0.111. Then this is 0 point something 38, 0 0.388, then 0 0.5. Then you can verify this later on. Okay, then you'll get 1 1 1 1. Okay, then step 3, we are going to multiply the result in step 2, multiply the result in step 2 by the maximum gray level value, which is 7, right, in this case. Okay, so this, now you have to write again 0 0.111 into 7, then 0.5 into 7, then okay, sorry, not 0.5, I missed one number, that is 0.388 into 7, then 0.5 into 7, 0.833 into 7, then 1 into 7 is 7, 7, 7 and 7, right? So this is how much we'll get, 0.777, right? This is 2.716. Then you get 3.5 here. Then you get 5.831. Okay, and this will be as it is, 777. Okay, 7777. This is like this. So after this, step 4, result of step 3, whatever we got here now, whatever we got, that we are going to round off. Okay, so result of step 3 is rounded to nearest integer. That is step 4. Okay, so what we'll get after rounding? We'll get for gray level 0, we'll get for gray level 0, we'll get 1. Okay, for gray level 2, sorry, for gray level 1, we'll get 3. Then 2 will get 4. For 3, we'll get 6. For 4, 5, 6, 7, we'll get 7, 7, 7, 7. Right? Now, step 5. In step 5, we have to map the gray levels by a one-to-one correspondence. Okay, I will show you how we are going to do this. So, mapping of gray levels by one-to-one correspondence. Okay, so we'll write a table, number of pixels, original gray level value and equalized gray level, corresponding equalized gray level. Okay, so number of pixels from the first table will get for this table. Okay, for the table which is given in the problem here. Okay, we'll get number of pixels. So you'll write number of pixels here, 100, 250, then 100, 300, 150, 0, 0, 0. Corresponding gray level original was 0, 1, 2, 3, 4, 5, 6 and 7. Now what we got here, from this table, step number 4, okay, you'll write here. So you got here 1, then 3, then 4, then 6 and then 7, 7, 7, 7, right? Now always you have to plot the original histogram as well as equalized histogram, okay, every time in the exam. So original histogram will be what? Number of gray level values versus frequency, okay, frequency of occurrence. So frequency of occurrence and what? Gray level values. Okay, so you have the 0, 1, 2, 3, 4, 5, 6 and 7, right? And here you can have 100, 150, 200, 250, 300 and 350. So 300 will be here and 350. Okay, so first 0, for 0 how much it was? 100, right? For 1 it was how much? For 1 it was 250. So you can plot here 250. Similarly for 2 you had 100 original histogram. For 3 it was 300. For 3 it was 300. Then for 4 it was 150. For 4 it was 150. For 5, 6, 7 it was 0, right? So this was the original histogram. Okay. After this you will plot the equalized histogram. Now equalized histogram, gray level values versus frequency, right? So here again you will have 0, 1, 2, 3, 4, 5, 6 and 7, and 100, 150, then 200, 250, 300 and 350. Okay, so for now for 0 it is 0, right? Now you can see this table. Here you can see 0 is not present, right? In equalized gray level values, 0 is not present. For 0, how many pixels are there? 0. So 0 will be 0. Now 1. For 1, how many pixels are there? For 1 you have 100 pixels, right? So we'll plot here 100. Okay. Then for 2, again you can check 2 is not present here. 2 is not present. So 2 gray level value is not there. Then for 3 how many pixels? For 3 it is 250, right? Okay. So you will plot here 250 for 3. Then for 4 how much? 100. Then for 5 is absent. So 50. Then for 6 is 300. Okay, 6 is 300. So here somewhere. And for 7, now you see here carefully. For 7, there are 4 entries, right? So always you have to add all the entries here. So how many are there? 150 plus 0 plus 0 plus 0. So for 7, it will be 150. Okay. So now you can compare the, sorry, I'm not drawing it properly, but now you can compare the original and equalized histogram. Okay. So this is about equalization, how to apply equalization.